Hi, my name is Jess, and I will be presenting vectors in 2D and 3D, and that's space. Okay, so here's a small introduction, things that you have to know before going into anything else about vectors. So quantities that only have magnitude, so magnitude is equal to quantity, are called scalars, and quantities that have both magnitude and direction are called vectors. So here's an example. Well, you can't see the rest of the image for some reason. But for example, this is going in a different direction than these two are, which means that it's negative. You could call it like a negative A, and these could be A, and this could be 2 times A. So the 2 times A would be showing the length or size of the vector, and the negative would be showing the direction, or the positive would be showing the direction. So yeah, and this is a picture of a plane. Okay, so you use real, like vectors in real life in problems with acceleration, force, displacement, and momentum. So mostly like physics. Adding 2D vectors geometrically. So this is not 3D, and 3D means that there's 3 planes perpendicular to each other, and you guys will see that later on in my presentation, but not yet. So for example, you have A and you have B, and here, if you put these two together, this would be the distance between them. And something you have to keep in mind is a 0 vector, so obviously direction. So if you add a negative A to a positive A, it's going to come out to 0, obviously. Subtracting, it's pretty much the same thing. So when you have a negative, it goes in a different direction. So if you were to be given A and B, and they ask you to do A minus B instead of A plus B, this is what it would look like. Okay, so here are some displacement problems. So we have an algebraic and a geometric version. So a runner runs east for 4 kilometers and then south for 2 kilometers. How far is she from her starting point and in what direction? So, okay. Does anybody have an idea on how we would do this? Could we use the Pythagorean theorem?
Use the Pythagorean theorem.
Okay. So what that would be is okay, and then this would be 16 plus 4 is equal to x squared, and then 16 plus 4 is 20, and we take the square root of 20, and that's equal to about 4.47. So what direction was she going in? If this is west and this is south, we could say that she was going southwest. Okay, cool. And then geometrically. So the thing with geometrically is you can describe it like this. However, it's just saying that P to R has the same origin and destination as PQ plus QR. It doesn't necessarily mean that this number, whatever this is, and plus this number is equal to this number, because that's obviously not true. This is going to be less distance. Okay, 3D vectors. So remember how I told you guys that 3D means that there's 3 planes or lines perpendicular to each other. So this would be a 2D version of a 3D model, and this is what it would look like if it were a 3D model. So the origin of all of this is specified as O. Through O, we draw 3 mutually perpendicular lines and call them X, Y, and Z axes. And you can't really see what that says on the board, but any point P can be specified by an ordered triple of numbers X, Y, and Z, indicating the steps in the X, Y, and Z directions from the origin to P. So for example, you could do like 3 steps in this direction, 3 steps in this direction, or really, if you wanted a point, I wish I had a 3D model, but I don't. But let's say there's a point here, it's how much steps from the origin in each direction to get there. And those are shown right here. So you have one X, Y, and Z coordinate. And then this you have to remember for later, because this is you can't really see it. Oh, I wish it was like dark in here. Anyways, this is the, is it complete? No. like when you take the value of that and it's not negative or positive, the magnitude. Okay, so the rules for algebra with vectors readily extend from 2D to 3D, so when adding them, you do the same thing. You just add across. So for example, A and B, these are the two magnitudes, you add those and you get, this would be, whatever your answers are here. So if this is 1 and this is 2, it'd be 3. A plus B would be 3, and then the other numbers. Same thing with subtraction. So here's an example. This is this is A, point B, point C, and point D. And we don't know these 2 points, but we do know these points on the 3D example. So here, So A, here are the 3 points, so we have those, B. Did I do this wrong? I don't think so. Anyways, so you subtract them, and this is what you get. And then using this answer, you can find, because they're all the same distance from each other, you can find C, or even D from there. And you can see that process. Okay, scalar multiplication. There's 2 different things that you can't confuse. There's a scalar product and scalar multiplication. Scalar product is the product of 2 vectors that result in a scalar answer. And scalar multiplication is the product of a scalar and a vector to give a parallel vector. So parallel line, that's what a parallel vector would look like. Here's an example of scalar multiplication drawn out for you. So it's just adding magnitude to it. So you just have more of it. And this is the answer. So if you multiply -1 by v, you have to do it to both v1 and v2. That becomes this, and eventually ends in -v. The scalar would be multiplying these 2 together. So it would be v1 times w1, v2 times w2, v3 times w3, and you have to add these 3 to get the answer. Okay, so scalar product 2D and 3D continued. Algebraically, we can look at it algebraically and geometrically. Algebraically, it looks like this, and these are the 4 ways that you know from basic algebra that you can, it's the same to multiply -2 by 1, then to multiply 1 by -2. It's the same to do 1 times 1 and 1 squared. Sure what these are. Oh, this is supposed to be right here, like the absolute value lines. They're supposed to be okay. And basic knowledge that you have to know. Here's an example. So for example, P are these 3 points and Q are these 3 points on a 3D model. And to multiply them, you would just carry it out across like this, and then eventually resulting in -4. We can take that answer for, well, let me wait for that. For non-zero vectors, so anything that's not 0, these will always be perpendicular if it's equal to 0. And the absolute values, remember previously I told you guys about to remember this absolute value equation, sorry. So whenever you have a problem like this, you have to remember this and plug in these numbers into this equation. So, for example, you also have to remember these 2 rules. So if the angle between these 2 vectors is greater than 0, then that means that the product is going to be greater than 0, and if it's going to be acute. These 2 are supposed to be reversed. I'm sorry, guys. Anyways, so we have this problem, and we used the previous answer, -4, for this. So we have P times Q is equal to magnitude of P times the magnitude of Q cosine, and then bring cosine to the other side, theta P answer because we already found this one. And then this will be 4 plus 9 plus 1. And I already solved this out before, so we didn't have that much to do. 4, which is equal to negative 4 over the square root of 70. Then theta is equal to, we bring cosine to the other side and invert it. 4 over this is about equal to 1,9 degrees. And we knew that it was going to be, since p times q was less than 0, we already knew from the beginning that the angle was going to be obtuse. I mean a cube, sorry. So, yeah, that's it.
Okay. Right. Thank you.